In this video, we'll continue to study area and look at area, but now we're going to look at the shape of a parallelogram. Okay, we've already taken a look at rectangles, and rectangles are pretty straightforward. On the background, you can see I've added a grid. So if we think about a rectangle, once again, and let's say we have a rectangle that's 3 units high, 3 squares high, and 4 units wide, then it would be easy to calculate the number of square units inside because we have 3 rows of 4, or you could say 4 columns of 3. And it becomes 3 times 4. This would be 12 square units. All right. If we had inches or feet, we could apply it to that. Parallelograms, though, are similar, but they don't have squares that nicely fit in them at first. And you can see this on the page, but I'm just going to try and show you in the video. Let me make a parallelogram with a base of 1, 2, 3, 4, 5. I'll just make that a base of 5 from there to there. And then, of course, parallelograms don't have a 90-degree angle unless they're special parallelograms called rectangles. Let's look at what if there was an angle to it. So let's take a look at this angle from here to here, and I'm going to draw the same slope there so that it's parallel. Now this is a parallelogram. This side is parallel to that side. This side is parallel to this side right here. How do we get squares fitting nicely in there? Well, you can see from the picture that they don't fit nicely in there. Some of the squares seem to fit nicely in the picture, and some of them are kind of cut or halfway. Well, the idea is you make a trim. If I were to trim this right here, notice that there's a triangular piece right here. I could kind of cut that off. Imagine if I cut that off, remove it, and replace it over on this side of the figure. So I'm going to redraw it over there. It would fit right in the edge of this, and it would actually make that squared up. Can you see how I moved that over? Well, what is my new shape that I've made? If I've essentially removed this piece on the left and I have this piece on the right, can you kind of see how that would be a rectangle? Let me erase the left-hand side so you can take a little better look at that, all right? If I were to erase that piece that I moved, you can see I now have a rectangle, and what does it have? It still has that base of 5, right? This 5 goes from here to here because it still matches the top 5. But the height now is what's important and not the slant. The height is 3, so this would just be nothing more than 5 times 3 to get the area. The area would be 15. So it turns out you can use the same basic principle to find the area of a parallelogram, that you need the base length and the height, just like a rectangle. Now, the difference is when we have our parallelogram typically drawn, I'll just draw one more here, all right? This is our base length from here to here, or it can be given on top. The height will not be this slant piece. That diagonal piece is actually longer than the height, right? The height would be, if we just go straight up, top to bottom, that is our height of our parallelogram, not the slant. The slant, if you look at it, there's like a little right triangle there. The slant is the hypotenuse of the right triangle, and it's actually longer. So we have to be very careful that we're measuring that base and that height, okay? I think that example should get you there, and there's a couple more below this.